Okay, this video is to finish up section 2.4 for my STAT110 course. Okay, so let's consider the example starting on page 47, example 2.4.2. And this again is about the question from the Star Tribune, do you support or oppose stricter gun laws in the United States? But what we have here is broken out that information from younger people, so 18 to 49-year-olds, and also 50 and older, so kind of two groups. Okay, so here's what those proportions look like. Again, I'm not going to worry about the undecided group. I'm just going to build margin of error quantities for those that support stricter gun laws. So what I'm really interested in is these bars that are on the left in this screenshot here. Okay, 59% of the 18 to 49-year-olds support stricter gun laws, and 53% of the 50 and older. Again, the 59% is just for the people that took the survey. So that was the 176 divided by the 299. We also have the 50 and older, which is the 172 divided by the 324. So that gives me 53%. I know that these quantities are going to change if I were to go get another set of data. Okay. So the margin of error is going to tell me how much those quantities change. Again, the calculations for that, if I'm interested in the margin of error, I'm just going to take 1.96 multiply by this quantity right here, which is that standard error quantity. I'm going to go ahead and open up a Google Sheet here, or a Google Doc, and show you how to do those calculations inside of a Google Doc. So that's what I have here. Okay, so let's go do that quick. Just go find a Google Drive, open up a spreadsheet here. Anything will work. Maybe blow that up a little bit so you guys can see that. And we'll just call this margin of error calculations. So I'm doing this for two different groups here. So let me go ahead and do that, excuse me, as I have on the screen there for you. So age group 18 to 49 and 50 and older. And then the margin of error calculation will be put here. Okay, so to do the calculation, again, all I need is the 1.96 multiplied by the square root of my pi hat quantity times 1 minus pi hat, all divided by my n. So the pi hat quantity is just the proportion or the percentage that's support for that particular age group. So the pi hat quantity here is going to be that 59%. The n, the total number of people in that age group, is over here at the 299. Okay, so let's go ahead and carefully type this into our spreadsheet. Again, maybe blow that up a little bit more so you can see that a little bit. So here I'm going to have equal 1.96 times the square root of, what was the proportion? 59% if I'm doing the younger group. So 59, 0.59 times 1 minus the 0.59. Sorry about that. So I need all of that. Okay, I have extra parentheses in here, but that doesn't, just trying to keep everything organized. So 59 times 1 minus the 0.59. All of that divided by the total number in that group, which was the 299. Okay, and all of this information needs to be inside of that square root, which I have it here with the square root parentheses and parentheses. Okay, and it looks like I have a space in there. So now it's actually going to do the calculation. So maybe you saw that The reason it didn't do the calculation is because I need to make sure and start that cell with an equal, and I actually started it with a space there. So there's the margin of error value, 0.0557 or so. Well, if we round that to 0.056, I guess, or 5.6%. You could write that a variety of ways there. Okay? So that's going to be the margin of error quantity for this 59. So how much can I expect this 59 to vary over repeated sampling? Well, that's about 5.6%, I guess. I would expect that 59% to go up by that 5.6% or that 59 to go down by that 5.6%. If I do the 50 and older group, I can do the same kind of calculation there. It's 1.96 times the square root. I'm using 53 now instead of 59 because that's the proportion that supported for that older group. And also the older group had 324 instead of the 299. And for that one, you can see that it's about 5.4%, I guess. Okay, so that's the easy way to compute these margin of errors quantities. You can obviously do it on your phone as well, but if I need to do one or more of these, I just usually drop it into a spreadsheet and just use the spreadsheet as my calculator, I guess. So these are the margin of error quantities. If I want the confidence intervals, what I need to do is take the proportions. So again, for the 18 to 49-year-olds, I would take the 59 minus the 5.6%, and then I would take the 59 plus that 5.6%. And when I do that, I get a range from about 53 up to 64. So like we were talking in class today, I can say for the 18 to 49-year-olds that a majority would support stricter gun laws, because that lower end of that range of likely values stays above 50% here. However, I cannot make that claim for the 50 and older age group. So the range of likely values goes from about 48% up to about 58%. So I cannot say that a majority are going to support here, because that lower range of a likely value, right, dips below 50% a little bit. All right, a little bit down here on the bottom of page 48, one thing that happens is that sometimes people want to know how many people to put into their survey. So that's called a sample size calculation. So how that actually is done is if we look at the margin of error formula, we can do a little bit of algebra and solve for n. So we could write this as n equals something. And I've done that algebra here for you. So let's suppose somebody is going to get ready to do a study, and when they get their outcomes, they want to be within 3% of the true outcome. Okay, so they want a margin of error within 3%. So we can put 0.03 in here and figure out what sample size would guarantee, or at least ensure, that the margin of error would be 3%. And for this particular situation here, okay, which is the 28, what am I doing here? 28. It looks like I just made up a value here for that pi hat value. So let us suppose that the estimated pi hat value, okay, they believe that'll be around 28%. So I guess that says it right here. Suppose we want a 3% margin of error, and it is believed that the value of pi hat is close to 28%. So we would use 0.28 in there, 1 minus 0.28. My desired margin of error is 0.03. Do all of this algebra here, and it says that you need about 860 people in your survey or in your study. If you use 860 people, okay, if you use 860 people, you're going to have about a 3% margin of error. So if you want the margin of error to be 2% instead, you're going to have to go get more people than the 860. So again, if you want to drive down your margin of error, you need to go get more people to put into your study. So this is a common thing that we statisticians do, is we do a sample size calculation, which again is how many people do you want to put in your study in order to get a certain level of a margin of error. And that calculation is done here. All right, so that's all we got for section 2.4. Thank you for listening.